At the very end of its life, our sun will gently shed its outer layers into the dark void. It will bypass a massive supernova explosion entirely, letting its stellar materials simply float away. This process leaves behind a small, glowing remnant called a white dwarf. The way these remnants behave provides the explanation for a significant observational gap in the night sky. In the nearly 14 billion years since the universe began, billions of stars have already lived, burned through their fuel, and died. Eventually, a dead star is theorized to lose all its heat and turn into a cold, dark lump of carbon known as a black dwarf. Yet, when astronomers look into the deep reaches of space, they cannot find a single black dwarf. Every stellar corpse we can see is still emitting light, leaving the final stage of stellar evolution completely empty. Understanding why these stars haven't gone dark requires looking at the extreme physical properties of the white dwarfs themselves. As soon as a star collapses after shedding its outer layers, the core becomes incredibly compact. The entire mass of the sun compresses into a sphere the size of Earth. The density is extreme. A single teaspoon of this material weighs as much as an elephant. A newly born white dwarf is incredibly hot, with temperatures exceeding 180,000 degrees Fahrenheit. Even at these temperatures, the star is dead. It is no longer producing any new energy to sustain its glow. Logically, an object that isn't generating new heat should cool down and go dark quite quickly. But space is a near-perfect vacuum, meaning there is no matter surrounding the star to carry heat away. This diagram illustrates how the dead star can only lose its heat through the slow process of radiation. It acts as a giant cosmic thermos. The star's internal density, combined with the insulation of the vacuum, traps its remaining heat for an immense amount of time. Because radiation is so inefficient, it takes trillions of years for a white dwarf to lose its heat and turn into a black dwarf. That trillion-year timeframe dwarfs the current age of our universe, which has only existed for 14 billion years. Black dwarfs are missing because the universe simply isn't old enough for a single one to have formed yet. This means that nearly every white dwarf created since the dawn of time is still visible in the sky tonight. The absence of black dwarfs serves as a testament to the relative infancy of our universe. This long-term cooling process also represents the ultimate fate of our own solar system. Long after the Earth has disappeared, our sun will slowly radiate its final degrees of heat into a darkened universe. Eventually, it will become a silent, invisible, frozen lump of carbon drifting through the endless dark.